I'm going to do two more examples here of converting from vertex form into standard form. And so these ones are a little bit more complicated than the first one that I did, but just by adding in one extra feature. So again, you'll notice here that for this first example on the left-hand side, again, we have a perfect square. We've got x plus 6 all squared, and we can expand that out in order to turn this into standard form. So what I'm going to do is I'm going to write this as y is equal to 2, okay, and then I'm going to expand out the x plus 6 all squared so that it's x plus 6 times x plus 6, and then plus 7, because I haven't dealt with that plus 7 at the end yet. So what I need to work with at this point is I need to work with this component, okay, right in the middle. I need to turn that into, I need to expand that out. I need to multiply those two binomial pieces together. So what I'm going to do is I'm going to do that multiplication. I'm going to get, again, x times x gives me x squared. X times 6 is positive 6x. Positive 6 times x is also 6x. And 6 times 6 is positive 36. So I'm going to also collect my like terms now. So I've got 2 times x squared plus 12x plus 36. That's all in brackets. And then finally plus 7. So what I'm left with here is y is equal to 2 times everything in this bracket. So the 2 actually gets multiplied, or actually multiplies that piece times that piece times that piece. So my next line has to be 2 times x squared plus 2 times 12x plus 2 times 36. So I'm going to go through and I'm going to do that. I'm going to multiply those pieces together, and that's going to leave me with y is equal to 2x squared plus 24x, and 2 times 36 gives me 72. And then now that I've done all my multiplication, I still have that plus 7 there at the end. So my final answer is going to end up being y is equal to 2x squared. Let's try that. 2x squared plus 24x plus 79. Okay, because 72 plus 79 gives me, 72 plus 7 gives me 79. So now I'm going to do another example here on the right. Okay, I have the same process at play, and I'm going to go through and I'm going to solve that again. Okay, so I've got y is equal to negative 3 times a perfect square plus 19. So I'm going to write this out as y is equal to negative 3 times, in brackets, x plus 1 times x plus 1, all plus 19. So I'm going to multiply using my FOIL pattern. I'm going to multiply these two binomials in the middle together. So x times x gives me x squared. X times 1 gives me x. 1x times 1x gives me a second x. And 1 times 1 gives me 1. And again, plus 19. You got to keep bringing that plus 19 down because we haven't dealt with it yet. So now I'm going to simplify the inside here. So y is equal to negative 3 times x squared plus 2x plus 1, all plus 19. Now, in order to continue working with this, I have to use my distributive property, and I need to multiply this negative 3 times x squared, negative 3 times positive 2x, and negative 3 times positive 1. Okay, so I'll need to multiply, using the distributive property, everything in the brackets by that negative 3. So in order to do that, I'm going to write y is equal to negative 3x squared times negative 6x times minus 3, and then plus 19. Okay. So my final answer here is going to be y is equal to negative 3x squared minus 6x plus 16. Okay. So I've just gone through and I've used my skills for multiplying and completed that piece.